The Ring of Fire has long been recognized as one of Earth's most active and volatile geological zones. It stretches around the Pacific Ocean, forming a horseshoe-shaped boundary where tectonic plates interact. This dynamic region is responsible for some of the planet's most devastating earthquakes and volcanic eruptions. Over the past few decades, significant seismic activity along the ring has drawn global attention, with many questioning whether Earth's most volatile region is waking up once again. In this article, we will explore the recent surge in seismic activity along the Ring of Fire, the geological mechanisms that drive this unrest, and the potential implications for the world's populations. Understanding the Ring of Fire is key to grasping the broader dynamics of Earth's geology and anticipating future risks. We'll define the region, look at key subduction zones and tectonic boundaries, and review significant historical events that have shaped our understanding of this active zone. The Ring of Fire is a term that has long been associated with the Pacific region due to its exceptional volcanic and seismic activity. This vast and dynamic zone is not just a continuous ring, rather it forms a horseshoe-shaped arc around the Pacific Ocean, stretching from the western coasts of the Americas across the Bering Sea and the coasts of Asia and the Pacific Islands and down through New Zealand. At the heart of the Ring of Fire's seismic activity lies the interaction between several tectonic plates. The Pacific Plate, one of the largest and most powerful plates on Earth, is surrounded by smaller plates, including the North American, Eurasian, Philippine, Indo-Australian, and Antarctic plates. The boundaries where these plates meet are critical to the region's seismic volatility. The primary mechanism driving activity in the Ring of Fire is subduction, where one tectonic plate is forced beneath another. This process generates immense pressure and can result in volcanic eruptions and large-scale earthquakes. Subduction zones within the Ring of Fire, such as the Japan Trench, the Peru-Chile Trench, and the Kuril-Kamchatka Trench, are particularly prone to intense seismic events. The Ring of Fire is also famous for its volcanoes. These volcanoes are often the result of subduction, where molten rock rises to the surface after a plate is pushed beneath another. The Pacific Ring boasts some of the world's most active volcanoes, including Mount St. Helens in the United States, Mount Fuji in Japan, and Mount Pinatubo in the Philippines. The presence of volcanic arcs along the Ring of Fire also contributes to the formation of islands, such as Indonesia and the Philippines. These islands are home to numerous active volcanoes that serve as a constant reminder of the tectonic forces shaping the region. The history of the Ring of Fire is punctuated by numerous catastrophic seismic events. Some of the most notable include the 2004 Indian Ocean tsunami caused by an earthquake along the Sunda Trench and the eruption of Mount Krakatoa in 1883. These events highlight the destructive potential of the Ring of Fire and underscore the need for vigilance in the face of ongoing seismic unrest. Historically, the Ring of Fire has been responsible for some of the largest and most deadly earthquakes and volcanic eruptions in recorded history. Earthquakes in the region can reach magnitudes well over 8.0, and volcanic eruptions can displace millions and cause widespread destruction. For instance, the 2011 Tohoku earthquake and tsunami in Japan, which registered a magnitude of 9.0, led to the Fukushima nuclear disaster, demonstrating the far-reaching consequences of seismic activity along the Ring of Fire. In recent years, there has been a noticeable uptick in seismic activity within the Ring of Fire. Scientists and seismologists are closely monitoring this phenomenon, analyzing data from seismic stations and satellite imagery to track the movements of the tectonic plates in real time. Recent data suggests an increase in the frequency and intensity of major earthquakes and volcanic eruptions in the region. For example, in 2020, the Philippines experienced a series of eruptions from Taal volcano, one of the most active volcanoes in the world. Similarly, in 2021, the eruption of La Soufrière in St. Vincent, although not directly within the Ring of Fire, is part of a broader pattern of heightened volcanic activity in the Pacific region. Scientists are observing similar patterns across the Pacific Rim, with increased seismic activity in areas such as Alaska, Japan, and Indonesia. These regions have seen more frequent earthquakes and eruptions, signaling a potential awakening of the geological forces at play. While these events are not unprecedented, their intensity and frequency have raised concerns about what might be unfolding beneath the surface of the Earth. The question remains, is the Ring of Fire truly waking up, or is this just part of the natural ebb and flow of geological activity? To answer this, scientists need to examine several factors. 1. The movements of the Earth's tectonic plates are not uniform, and these plates do not always move in predictable patterns. Stress and pressure can accumulate over time along plate boundaries, leading to sudden releases of energy in the form of earthquakes and volcanic eruptions. 2. While climate change primarily affects surface temperatures, there is some evidence suggesting that it could indirectly influence seismic activity. For example, rising sea levels and melting glaciers may alter the weight distribution on the Earth's crust, potentially triggering seismic events. Additionally, changes in the Earth's inner core and mantle dynamics could affect the activity of volcanic regions. 3. In certain areas, human activities such as deep mining, hydraulic fracturing, fracking, and geothermal energy extraction can trigger earthquakes by inducing stress on the surrounding rock. While these events are typically not as powerful as natural earthquakes, their cumulative effect could contribute to the overall pattern of seismic unrest. As seismic activity continues to rise in the Ring of Fire, the potential implications for global populations become more pronounced. Millions of people live in areas directly impacted by the ring's geological forces, particularly along coastlines prone to tsunamis and near-active volcanoes. The destruction of infrastructure, loss of life, and displacement of communities are all significant risks associated with increased seismic unrest. In addition to the immediate physical impacts, there are long-term consequences for the global economy. Many of the countries bordering the Ring of Fire are highly industrialized, and a major earthquake or eruption could disrupt supply chains, affect energy production, and lead to significant economic losses. For example, the 2011 Tohoku earthquake caused widespread economic damage not only in Japan, but also throughout the global supply chain, particularly in electronics and automobile manufacturing. Moreover, the environmental impact of increased volcanic activity cannot be overlooked. Eruptions can lead to climate cooling, as ash clouds can block sunlight, and the release of sulfur dioxide into the atmosphere can lead to acid rain and crop failure. These environmental disruptions, compounded by the direct effects of seismic events, make the Ring of Fire one of the most dangerous geological zones on Earth. The recent surge in seismic activity along the Pacific Ring of Fire has captured the attention of scientists, policymakers, and the public alike. While it is difficult to predict with certainty whether the region is indeed waking up, or if this is simply a cyclical phase of heightened activity, there is little doubt that the potential risks are substantial. As we move into the future, it will be crucial to continue monitoring seismic trends, invest in disaster preparedness, and develop mitigation strategies to minimize the impact of earthquakes and volcanic eruptions. Ultimately, understanding the dynamics of the Ring of Fire is not only key to predicting the future of seismic activity, but also to safeguarding the millions of lives that reside in one of the most geologically active regions on the planet. As the Earth's most volatile region continues to shift beneath our feet, the question remains, will we be ready when the Ring of Fire decides to unleash its full power once again?